Good morning and good afternoon and good evening and even good night to everyone who is tuning in for session 4 of Beyond Genes. We're very happy to have you no matter where you are in the world. I'm Jill Escher, I'm the conference chair, and we are now past our halfway mark into session 4. I want to thank our sponsors who have all helped put this session together, in particular the John Templeton Foundation for the financial support. I want to thank our committee. You have all put together a wonderful program, and we've actually added a little bit to it, which I'll talk about in a second. This conference, as you know, it takes place across 6 sessions. We've finished our first half, and now we're into our second half, which really shifts gears to look at particular exposures for which there is particularly strong and growing evidence for heritable impacts in mammals and humans. And today, of course, we're focusing on tobacco, cannabis, and related products. And the theme across all of our sessions is really one thing, that heritability is greater than just DNA. We are pleased to say that due to demand for some less formal and more interactive content, we are hosting 3 holiday hangouts the week of December 14th. We may add some additional PIs to this listing, but if you are interested, you simply go to our website, beyondgenes.org. There's a tab for holiday hangouts and sign up there. There's no cost to register. And finally, oops, I went the wrong way. How did that happen? Sorry. Logistics, we ask you not to record any talks, although I think that almost all of the talks from today will be recorded and posted. And if you have any questions, please put them in the question box, and our wonderful moderators, Rose Schrott and Jordan Buck, will handle those. And I'm now going to turn it over to Rose and Jordan.
Thank you so much, Jill. We just want to welcome everyone to the 4th session of the Beyond Genes online conference. It's been a really wonderful series, and we're really excited for all of the speakers that we have for you today. And with that, I will go ahead and introduce our first speaker. So our first speaker is Dr. Jean Golding. Dr. Golding is an epidemiologist whose work has focused on maternal and child health. She's devoted most of her research career to large birth cohort studies in the UK, and in the early 1990s, she initiated the Avon longitudinal study of parents and children, an in-depth study starting in early pregnancy and following parents and their offspring throughout infancy, childhood, and adolescence, about 14,000 children. She retired from the position of scientific and executive director of the study at the end of 2005, but continues to work on various aspects of the survey. In particular, she works together with Professor Marcus Pembry on inter- and transgenerational influences on health and development of the child. She is now an emeritus professor at the University of Bristol and has received honorary doctorates from Bristol and UCL, is a fellow of the Academy of Medical Science, and has received an OBE for her contributions to science. And now I will turn it over to you, Dr. Golding.
You've got, thank you very much indeed. I'm rather embarrassed by all of that. And good day, evening, night to everybody. So the title of my talk, as you can see, is Smoking in Pregnancy by the Grandmother and the Associated Outcomes in the Grandchild. Unfortunately, my system isn't working at the moment, so Rose is kindly going to change slides for me. So it's not surprising that smoking, particularly in pregnancy, has really deleterious effects on the fetus and later the child. As you can see, it contains all sorts of noxious things. Next. So what we know about the outcome of the immediate pregnancy, if the mother is smoking, is that the child is much more likely to miscarry. It's more likely, presuming it doesn't miscarry, to be born at lower birth weight, or to be born early, preterm, is more likely to die at stillbirth or in the first week of life. It's also more likely, if it survives that, to die suddenly of infant death, a so-called cot death or crib death. Next. I'm not going to go through the consequences we know about during childhood, but there are some interesting findings looking at adults. And these I've just picked out because there's really good data to show this. So if the mother has smoked during pregnancy, her offspring are more likely to be obese, particularly when they get to adulthood. They're more likely to have antisocial personalities or to be hyperactive. They're more likely to show schizoid tendencies as they approach adulthood, and to have frank schizophrenia by the time they're 40. Next. So that's the child of the mother who smoked. But what about the grandmother who smoked in pregnancy? First of all, there's the question of which grandmother are we talking about? Next. So here's the family tree showing the grandparents, the parents, and the grandchildren. Just to tell you what PGM means and MGM. PGM is the paternal grandmother, MGM is the maternal grandmother, and that is the nomenclature I'll use during this talk. Next. So if we're looking at the maternal grandmother who smokes, in order not to confound things by having a mother who smokes as well, which often happens if the grandmother smokes, for this presentation, I'm talking about the grandmothers who smoke and the mothers who don't smoke, and looking at their grandchildren to see whether there is any association with any of the factors we're looking at. Next. So for paternal grandmother, again, we take the children whose mothers didn't smoke in order to look at the paternal grandmother effects. Next. So the study that Rose talked about, which we know as ALSPAC, takes place in Avon, which is the red splodge there on the map of the United Kingdom. It comprises births that took place in 1991 to 1992 to residents of Avon, and there were about 14,000. Next. So the data that we collected used all sorts of different methods. So self-completion questionnaires that the parents, the teachers, the children completed, health records, biological samples, monitoring the environment, measuring their educational abilities, and a lot of hands-on assessments of the children. We won't go into details of any of that except one soon. Next. So this is the first thing we looked at, which is the birth weight of these grandchildren. So to do this, we compare the maternal grandmothers who smoked, mothers who didn't, with the maternal grandmothers who didn't smoke and mothers who didn't, and looked at the mean difference adjusted for various demographic features. And you can see there's a difference between the grandsons and the granddaughters. It's the grandsons that have excess weight over what you'd expect, excess length over what you'd expect, and a greater BMI, body mass index. So that's what happens at birth, and other studies have also found an increase in birth weight. Next. but what happens as the children grow. So this is looking at the differences in mean weight of these children or grandchildren as they develop. And you can see the difference in weight according to whether the grandmother smoked or not increases dramatically as the children get older, if they're boys. It doesn't affect the girls. Next. So we looked in more detail at the boys' anthropometry at the age of 17. So their weight was 2 kilograms greater than expected if their grandmother had smoked, and they had an increased body mass index. So one might assume that these are children that are developing signs of obesity. Next. However, body mass index is known to be an imperfect index of fatness. Total body fat mass is much better measure of adiposity. And here we've taken advantage of data that were collected on the children from the age of 9 onwards using a DEXA scan. And this partitions out the different types of tissue in the body, most particularly looking at the amount of lean mass and fat mass. Next. So here's the weight increase that we showed for maternal grandmother smoking in the grandsons. But you can see it's not fat mass that was causing that, it was the lean mass. Now the lean mass is mostly made up of muscle. And to test whether that's what we were looking at, we looked at measures we had of the strength of these boys. And lo and behold, it was true. The maternal grandmother smoking group were stronger than those if the maternal grandmother didn't smoke. Next. So this is looking at the lean mass, the difference in lean mass if the maternal grandmother smoked compared with if she didn't. And you can see for the grandsons, there's a dramatic increase, getting really strong by the time they're 17. Whereas for the girls, there's no such association at all. Next. However, for paternal grandmothers, we also had effects. Remember, we didn't have an effect for paternal grandmothers in looking at birth weight, but certainly once the children were born and were passing through adolescence, there were definite signs of an increase in lean mass in this population, and an indication that there was for the granddaughters early on. There's a lot that still we need to explore in this data. Next. So having looked at growth, we then decided to look at different aspects of development. We knew that maternal smoking affected the child's development in terms of cognition, in terms of various aspects of development, and to a certain extent with sensory outcomes. So we decided to look at those in regard to the grandmother smoking, starting with looking at the IQ. Next. So this is looking at the paternal grandmother smoking compared with if she didn't smoke. And there were associations with the performance IQ. I should say IQ, total IQ is made up of a verbal component and a performance component. So for the performance IQ, both the grandsons and the granddaughters had a lower IQ than would be expected. It's not that much lower. The number of IQ points in a standard deviation is 15, so you can put that together. And for the verbal IQ, it was the grandsons that had a lower measurement, and the granddaughters didn't. Next. Then we looked at the traits associated with autism spectrum disorder, or ASD. And this time it's the maternal grandmothers that were showing something. I should have said with IQ, maternal grandmothers didn't have any association. But for the autism spectrum disorder, there were associations with 2 of the 4 traits that we looked at. The social communication, if the grandchild was in the top, or i.e. worse level of social communication, and the maternal grandmother had smoked, then the granddaughters were more likely to be in that group, as they were for the repetitive behaviors, and they were quite strong effects. Next. However, if we looked at the diagnosis of ASD, we find that the grandsons had an excess, as did the granddaughters, although it should be remembered granddaughters or girls are less likely to be diagnosed, and particularly at the time these children were being diagnosed. So the odds ratios there are very similar for grandsons and granddaughters. Whether that will continue once we follow the children into adulthood, I don't know, but we will find out. Next. Then looking at eyesight, we wanted to look at eye conditions that were increasing in prevalence. So myopia is a case in point. We looked at myopia and found that there was no effect with paternal grandmother smoking, but there was with the maternal grandmother smoking. Sorry, I'm wrong. Let me start that again. We looked first at the maternal grandmother smoking, and what you can see is that the odds ratios are much less than 1. In other words, the grandchildren were less likely to be myopic at the age of 7. Myopia is also known as short-sightedness. Next. However, if we looked at the paternal grandmother smoking, the odds for the grandsons were much less than for the maternal, for the maternal grandmothers. So these grandsons were only 1/3 as likely to have developed myopia by the age of 7. Nobody knows quite why, but there was methylation support for this finding, and support for the finding that we showed epidemiologically, which was that the associations with myopia by the age of 7 were quite different from the associations found for myopia developing after the age of 7. So that was carried out by our colleague, Matthew Suderman, and is part of a publication. Next. we looked at hearing and looked there at a reaction to loud noise. So there are children who really hate loud noises. And we got the mother's report of the 6-year-old as to whether the child reacted adversely to a loud noise. And you can see that the odds for the grandsons, if the maternal grandmother had smoked, the grandsons were much more likely to have that adverse reaction, and the granddaughters less likely than you'd expect. And the interaction between the two, the statistical interaction, was statistically significant. Now that is a very subjective finding, because you're relying on the mother to say what a loud noise is and how the child's reacted. So next. The audiologist had, at the age of 11, created a test for the study children, whereby the child was given earphones and some sort of computerized sound. It was music of some sort. Was asked to set the sound to the level at which they preferred to hear it. So this is whether the child set it to the loudest level, so the 10% loudest levels in that range. And you can see the grandsons were setting the level much less likely to the loudest noise. Sorry, that was tortuous to say. The granddaughters were much more likely to set it to the loud noise. So that is supporting the hates loud noise type of pattern. We have a significant interaction between the sexes again. Next. So trying to put together the results of the findings we have so far, and I might say we've got a long way to go to look at all sorts of different aspects of outcomes. But there are differences. So maternal grandmothers had effects on fetal growth and autism traits and noise sensitivity that paternal grandmothers didn't. Whereas paternal grandmothers had effects on height, which I didn't talk about, and IQ, but maternal grandmothers didn't. And both of them had associations with lean mass and with myopia, though perhaps not to the same extent each time. Next. So you will have noticed there are sex differences between the grandsons and granddaughters. Here I've tried to categorize them so that the effect size of the grandsons was greater or much less than the granddaughter for fetal growth, for the lean mass, for strength, for myopia, for verbal IQ, and for noise sensitivity. Granddaughters had more effects than the grandson for height and for the 2 autism traits. And there was only one factor that I've talked about where they were roughly equal, and that was for performance IQ. One of the things that is striking, I think, next, is the fact that many of these findings are not adverse effects of the grandmother smoking, they are more beneficial. So the grandsons more likely to be larger during fetal life. During adolescence, he's getting much more in the way of muscular development. He's stronger. He's less likely to develop myopia. So all of that one could see as beneficial. Lower verbal IQ, maybe not. And I really don't know whether being sensitive to noise is good or bad. If we look at where the grandson is, has a lower level of effect size than the granddaughter, then height comes out. So it's just more than half of the factors we looked at shows some sort of benefit to the grandchild. Next. So the results of the grandmother's smoking, there are definite intergenerational associations between a grandmother smoking in pregnancy and the outcome to the child. But the patterns of the intergenerational heritability are really complex. And we need replication cohorts badly to try and find out how much of this has occurred by chance. But I might say that almost anything we look at, we find something. Next. So that's intergenerational. But what of transgenerational associations of the great-grandmother smoking? Next. Our wonderful ALSPAC cohort have recently been asked to ferret around and find out a lot of information about the study child's great-grandparents. So we asked the parents themselves, the mother and father, to find out as much as possible. So this data is only just available. So I'm telling you straight hot off the press what we found. Next. So there are 4 great-grandmothers for whom we have some information on smoking in pregnancy. Now, as you might expect, the paternal side is, how can I put this, are less likely to know about their ancestors than the maternal side. There is a definite ingrained interest among the mothers about their ancestors that doesn't seem to occur among the father's side, perhaps until they get a bit older. So we have looked at these 4 great-grandmothers smoking. Next. And again, we took well, first of all, the big association we found was with the maternal grandfather's mother, who's the one with the cross there. And in order to look at the outcomes, we took those whose maternal grandmother didn't smoke and the mother didn't smoke. So there's no maternal prenatal smoking further down the line. And the first thing we've looked at is methylation age of the grandchildren. Next. And this is something we put into a grant. So there was a long-term interest in looking at this. I didn't think we were going to find anything. We looked at 4 distinct measures of methylation age. And for those who don't know what it means, my understanding is that this is a biomarker that calculates the amount of methylation in certain sites that compares it with what would be expected for the biological age of the person. So this is taking the children, the grandchildren, at the same age and comparing their methylation ages, these 4 distinct measures are correlated, but not very strongly at all. It was, most studies looking at these distinct measures might find one associated with an outcome, but not others. However, to our amazement, next, we found 3 of the 4 were associated. P-int means the p-value for interaction was significant. And they all show the same pattern. So the great-grandsons all had a negative methylation age. The great-granddaughters all had a positive methylation age. So a negative methylation age, as I understand it, means that the biological marker indicates that the child hasn't aged as much as you might expect from his chronological age. And the positive is vice versa. Next. So that's as far as we've got. We haven't looked at any other phenotypes at all yet, and are obviously itching to do so. There are thousands of data points in this data set. So we're incredibly grateful always to the collaborators who have put ideas into what data we should collect over the last 30 years. The staff who have very loyally carried on collecting information with us, the funders who are legion, and the participants. Next. But most of all for this, the most important person is Professor Marcus Pembry, whose idea it always has been, and who has been instigating and masterminding the way in which we've carried out the research. Various researchers over time. Our funders for this project have been the John Templeton Foundation for the last 3 years, the Isha Fund, and the Medical Research Council earlier on. And we're still grateful to the participants who, during this last 3 years, have put so much time and effort into finding out about their ancestors. Thank you very much.